Alright, so we're going to go over some basic exponent rules. I'm going to go over all of them, and then we're going to use problems that kind of combine a lot of things. So the first one we're going to go over is what's called the product rule. Product, remember guys, it's just a fancy way of saying multiplication. So the product rule states that if you multiply two things with the same base, you add the exponents. So right here we got x squared times x to the third. And we just have the same base of x, and then we just add. 2 plus 3 is 5. So what this means is, the way it comes about is x squared means there's two of them. X to the third means there's three of them. If we multiply them all together, you get x to the fifth. There's 5 of them. Alright, the next thing, let's do a quick example of it. We got 2x to the second times 4x to the fifth. Now remember, when we're multiplying this out, guys, that 2 and 4 are still coefficients. They're still numbers you multiply just like normal. So that's why we get the 8. But the x to the second times x to the fifth is just the rule we talked about. 2 plus 5 is 7. Simple as that. Don't forget that you multiply the numbers and add the exponents. You cannot forget those simple rules. You can't mix them up. Don't forget the things you've learned in previous classes. We're back in elementary school. Alright, next thing. We got x to the 0. This is called x to the 0. So anything to the power of 0 is 1. So my recommendation is anytime you see anything to the 0 power, just scribble it out. Makes life a lot easier. Don't worry about why. Just make it x to the 0. So if you see a problem with x to the 0, just scribble it out. Makes life a lot easier. So here, we got 3x to the fourth times y to the third times 5x to the 0, y to the second. So there you go. I see an x to the 0. So the first thing I would have done is just scribble it out like it doesn't even exist. Doesn't change the problem or anything. So now we're multiplying. So we should multiply 3 times 5 just like normal. You get 15. We're not going to get 8. You just multiply. So now I have the x to the fourth, but I have nothing on the right side. So that's why x to the fourth is my answer. I have y to the third on the left and y squared on the right. Add them together and get y to the fifth. Simple as that. So one thing guys you're going to notice is all these problems are different. There's not one way of solving a problem. There's always multiple ways. And there's also different rules. So there's not a specific way of solving a problem. So that's why things can get difficult. So let's look at another rule. So our next rule will be, come on, x to the third over x squared. Now this is our quotient rule, division rule. Now what I would recommend to doing there, they would say subtraction, but let's think about this. There's 3 x's on top, and there's 2 x's on bottom. So let's cross them off. I cross off 2 x's. Now there's only how many left? There's only 1 left, and that 1 is on top. So that means that reduces down to just a single x. X to the first is fine. Now in this case, we have x squared on top, x to the fifth on bottom. What that means is we have, now if we were to actually apply the subtraction rule that I spoke about, on the top it would work. You get 3 minus 2 and you get 1, which would work. But in this case, if you took 2 over 5, you would subtract and give you negative. And I'm going to teach you here in a little later that you'd have to do another one. So this is what I would recommend doing. I would recommend thinking about the problem. Well, there's 2 x's on top. Now you don't have to write these all out every time, but there's 2 x's on top, 3 on bottom, or 5 on bottom. You can cross them off. Okay, well there's 3 left. Now the question is, where are those 3 at? If you imagine in your head, you're going to see it on bottom. But it's always where the bigger exponent starts. So if the 5 is on the bottom, it's bigger. That means you're going to have 3 of them left on bottom. So there you go. Now you can do the subtraction problem, but you have to apply the negative exponent rule, which I'll teach you in a little bit. But it's important to think how many's on top, how many's on bottom, cross them off, however many is left, that's where it goes. Alright, let's look at an example. We have 16x to the fifth all over 4x to the third. Now, do not forget your simple division. 16 divided by 4. It's not going to be 12. 16 divided by 4 is 4. So don't forget about your simple division. 4 is going to remain on top because 16 divided by 4. Now, if it was 4 over 16, it would be 1 over 4. But 16 divided by 4. Now, x's. 5 of them on top, 3 on bottom. In your head, cross them off. Okay, there's 2 left. Now, where do those 2 go? Well, then x to the fifth on top is bigger. So I'm going to put the x squared on top. That's why it goes on top. So there is my answer. And you can put it all over 1 if you want. It's up to you. But you don't have to. So this one we got 5a to the fourth, b to the seventh, all over 25a squared, b to the first. Now with this problem, I like to separate it into 3 problems. I got my 5 over 25, my a's, and my b's. So that's what I would do. So the first thing, 5 over 25. It's not 5 on top, it's actually going to be 5 on bottom. So 1 divided by 5. This is a fraction. Now my a's. I have 4 a's on top, 2 a's on bottom. Subtract them. I have 2 of them left. and there's 2 of them on top, because I cross off, and 4 is the bigger number. So we have a to the 4th over a squared, gives me 2 of them left over on the top. There we go, on the top. And my b's. Now, if there's a single b and there's no variable exponent, remember it's b to the 1st. So there's 7 b's on top, 1 b on bottom, cross 1 off, there's 6 of them left on top. So there's my final answer. If you separate a big problem into smaller problems, it becomes a lot easier for you guys. Alright, let's look at our next one. Remember, every problem is different. There's not one specific way of solving a problem. You have to figure out your way, and you have to find little things you can do. Break down a big problem into a little one. Our next rule is called power to a power. So what that means is we have x squared all in the power of 3. So what this pretty much means is that we have x squared times x squared times x squared. So there's 3 of them. And what that also means is there's, just like in the beginning, we talk about x squared, there's 2 of them, so x times x. And then if we follow our specific rule and go, okay, well that's 2 plus 2 plus 2, it means 2 plus 2 is 4, 4 plus 2 is 6. So a way to go without, can we just skip right to here and not do this step? Well, 2 times 3 is 6. So in a power to a power, we multiply my exponents. And that's the reason why right there. So 2 times 3, bam, 6. That's the power to a power rule. So let's look at an example. X to the power of 2 to the power of 4. Simple. 2 times 4 is 8. There we go. Now with all these rules, you can't get them mixed up. You got to know your rules. Got to know the simple rules. Now this is important to note. 2 times 2x squared to the power of 3. Now, we do distribute the 3 out. But the important thing to remember, the 2 in the power of 3, that's not 2 times 3. I'm talking about this, the first 2, the big 2. It's not going to be 6. So that 2 in the power of 3, it's not 2 times 3, it's 2 in the power of 3. So 2 in the power of 3 is going to give me 8. Not 2 times 3, it's not going to give me 6. But when I take that little exponent, 2, the power of 3. That's when you're multiplying x to the power of 6. So it's important to remember your rules and not forget when to apply them and when not to apply them. That's very important. So we have 2 times x to the 3rd power times y to the 4th, all in the power of 3. So same thing as before, we're just adding another variable. So once again, we're distributing that 3 out. So we have 2 in the power of 3. Once again, it's going to be 8. Remember, it's not 6. It's going to be 8 actually. So x in the power of 3 is going to be 9 because we multiply 3 times 3. And y in the power of 12 because I multiply 4 times 3. That's how it's done. Alright, next problem. So we are going to start combining some rules here. So 2 times x to the power of 3, y to the power of 4, all over x to the power of 2. Now, you can do a couple things. You can distribute the 2 out in the beginning. I don't care. But I usually recommend always work inside the parentheses first. Work inside the parentheses, then bring in the exponent. That's my recommendation for this problem. Don't worry about that square. That's all the way in the top right. I wouldn't even worry about that now. But let's focus on what we do on the inside. I have an x on top and an x on bottom. Let's cancel some out. The 2 doesn't change. That 2 is still there. If I cross them off, I'm left with 1x. And then I got y to the 4th. Doesn't change. Now, once I kind of make my life a lot easier, then I distribute that out. So 2 in the power of 2 is 4. 1 times 2 is 2. And 4 times 2 is 8. Now, if you would have distributed it out in the beginning, if you would have done that, you would get the same answer. But it just makes the life a lot easier for you if you figure out stuff inside the parentheses first, and then you bring in the power, just like at the end, like we did here. Like I said, there's not one way to do it. My way is not the only way. If you came up with a different way, that's fine. All right, next we're going to talk about the negative exponent rule. Now, the way I explain it and the way you're going to read it in notes or read it online, if I would have typed the negative exponent, it was a little different. So x to the power of negative 1. In my definition is anytime you see a negative exponent, you're going to send it to the opposite side of the fraction and change it to a positive, which means this. That's x to the power of negative 1. That's actually on the top of the fraction because you always can write anything under 1. So my recommendation is you move it to the bottom and change the sign of the exponent. Bam. Simple as that. So that means if it's on the bottom, you're going to send it to the top and change the sign. That's all you got to do. So just like here, there's x to the negative 4 on top. And there's a net y to the negative 3 on bottom. So that is what I'm moving. I'm moving that from the top to the bottom and changing that negative 4 to a positive 4. That's all I got to do. Now that y to the negative 3, I'm going to take that and move it to the top, and I'm going to change that to a positive 3. Now that z will not change because there's no negative. So that means I'm going to write a y to the positive 3 on top. And I'm going to write an x to the positive 4 on bottom. So they kind of just switch places, but I'm only allowed to do that because of the negative exponents, the original problem. That negative exponent tells me to move stuff. If there's no negative, you don't move it. And it's only the variable. You do not move anything else. So you don't move multiple things. You only move what it's applying to. So in this problem right here, so you have 18x squared, y to the negative 4th, all over 3x to the negative 3, y to the 5th. So what I always like to do is split the problem up, but I also like to move things. X, 18 over 3, 6. Simple. So that x on the bottom, that negative 3, that has to be moved to the top. So what we're going to do is we're going to scratch that off, and I'm going to write it right next to it, kind of make life a lot easier. And you see it had changed to the third power. Now we're going to apply another rule, our product rule. I have x to the third on top and x squared on top. All we have to do is add those together and get x to the 5th. Pretty simple. All right, the y's. Now I have y to the negative 4, it's on top. Let's move it to the bottom, and it becomes y to the 4th. Once again, product rule now. Y to the 5th times y to the 4th is going to be y to the 9th. So you can see I applied a lot of different rules in this problem, but I broke it down, made life a lot easier for me. All right, next problem. Once again, we're combining stuff. We have b to the negative 4th, b to the 2nd, and b to the negative 3rd. And then to the power of 4. So what I would do is do stuff on the inside. I have two negatives, so let's move them first. I always like to do that. It makes life a lot easier for me. So we have to move numbers first, and then we're going to apply that 4 at the very end. So what I would do is move that b to the negative 4 on the bottom, but that b squared is never going to change. That b squared is just b squared because there's no positive. So I move that b to the negative 3 on top. It becomes positive. I move the b negative 4 on bottom. It becomes positive. Now let's look at the top. I have b to the 3rd on top along with b squared. Let's add those together. Gives me b to the 5th. Bottom doesn't change, b to the 4th. So now what we're going to do is we're going to keep going. I have b to the 5th on top, b to the 4th on bottom. That gives me b to the 1st because I took 5 minus 1. Now, makes life a lot easier. Look how easy that is. Now, if I went to the beginning and distributed that 4 out, yeah, you're going to get the same answer, but you're going to get bigger numbers. More room for error. But I would recommend just worrying about what's on the inside first, because you can see there, I just applied a couple different rules, one thing at a time, and life became a lot easier for me.